Okay, next is the summing amplifier. Okay, summing amplifier, we have the inverting summing or non-inverting summing. So summing amplifier is a good example of analog circuit serving as analog computing amplifier or analog calculator. So analog circuit can add, subtract, multiply, divide using logarithmic component, differentiate, and integration in real time and continuously. Okay, so this is the motivation in the earlier years of development of amplifier. So use the amplifier to do the mathematical operation. Okay, so this is the inverting summing amplifier. So inverting summing amplifier is the configuration is quite similar to the inverting amplifier, but the difference is you have a multiple input connected in parallel. So for inverting amplifier, you only have V1 R1 here, but for the summing amplifier you add V2 V3 until Vn if you have the n input. Okay, so let's say you consider the input is until the 3 input. This is the V3, this is the I3. Okay, there is a two-way to do the analysis. You can do the superposition. Superposition means that you ignore V2, V3, you analyze the V1 only, and then you do that. You repeat that analysis for V2 and V3, and then you combine all the result. Okay, this is another one approach. But for this course, we go for the very simple approach, straightforward approach, not simple, straightforward approach. So we just do the KCL. So we do the KCL at this point. So remember that this point and this point is the same point. This is a same point. Okay, I1, I2, and I3, the direction is given. IF also is given. Okay, so you do the KCL here. So the KCL is equal, we have the entering current is I1 plus I2 plus I3, and then the feedback current is exiting, so this is your IF, and we have here actually we have the input current is 0, so this is 0, you can ignore it, and then this is equal to 0. So next, every current term need to be represented using the Ohm's law. So I1 is equal to V1 minus V negative over R1. So I2 is V2 minus V negative over R2. V3 is V3 minus V negative over R3. And IF is V negative minus V out over RF. This is equal to 0. Okay. Now the V plus is equal to V negative is equal to 0 because this is grounded. So you can modify the above equation as V1 R1 plus V2 R2 plus V3 R3, and then this is plus V out RF equal to 0. And you get this one is V out is equal to negative RF R1 V1, and then this is a negative RF R2 V2 negative RF R3 V3. Okay, so this is the answer for the inverting summing amplifier. Okay, this is the superposition of one. This is the term number 1 is the inverting amplification of the input 1. And you have the second term is for the input 2. The third term is for the input number 3. So you just superposition all of them, and then you can get this answer. But in our class, we do the KCL and then we get the answer. Okay, the summing or to add the signal can be done non-inverting. So in the previous example, so the gain is negative, so the output, although we add all the output, but the total is negative because this is a inverting. So we can also get the non-inverting. For the non-inverting, we do the same analysis. So we have two nodes here. Let's say this is our node number 1 and this is our node number 2. Okay, we start with the KCL at the node number 1. Okay, for the KCL, need to label the current. So this is your IA, and then this is the IB, and then this is I equal to 0. So node 1 is IA plus IB equal to 0. So IA is VA minus V plus over RA plus, this is VB minus V plus over RB equal to 0. So this is VA RA plus VB RB minus V plus, this is RA plus RB equal to 0. So you get V plus is equal to RA plus RB, and then this is your VA RA plus VB RB. Okay. So you have defined the V plus here. Okay. So next you do the KCL. So KCL at the node number 2. So KCL and node number 2, so you have, this is your IF, and then this is your I1, and this is I equal to 0. So entering is the IF, so IF is positive, I1 is negative, equal to 0. Okay, IF is V out minus V negative over RF, and I1 is V negative minus 0 over R1 equal to 0. So now the V negative is equal to R1. Oh, sorry, not correct. Forgot the term. Need to expand this, the first term. So from the first term, V out RF minus V negative, and then this is the R1 RF over R1 RF equal to 0, and then you will get V negative here is equal to R1 RF R1 plus RF. Okay, correct. So V out over RF. Okay, so we have equation for V plus and V minus. So these are equal. So V plus equal to V minus. So V plus is equal to V minus. So V plus is RA RB okay, RB, and then you have here VA RA plus VB. RB for the V negative is R1 RF V out. This one is R1 RF R1 plus RF V out over RF. Okay, lastly, you solve this one. This is your V out is equal to okay, you can solve this one. This one is the R1 plus RF over R1, and then this is RA RB RA plus RB VA RA plus VB RB. So this is the derivation of the output for non-inverting summing amplifier.